Hello, this is Mr. Zanetto, and we're going to go ahead and look at some proofs. This is topic 8, and we have the parallel lines here given to us in this first proof. So we always want to go ahead and state our given and then go ahead and write that that was why we know this to be so, is that it was given. From there, we look at what we're trying to prove. When we look at what we're trying to prove that this angle is congruent to this angle. And we have some nice theorems to do that. Obviously, here we're basically proving that the alternate exterior angles are congruent. We can't use that since it is a theorem. We're going to try to avoid that. And in this situation, we have parallel lines. We have labeled angle 2, angle 4, and angle 6. Well, angle 2 and angle 4 are vertical angles, and then the vertical angles, that 4 corresponds with 6. And we can link it all together with transitive properties. So that's sort of my gut feeling, the plan, based on the way it's labeled and what we're trying to prove. So let's go ahead and try that. Angle 2 is congruent to angle 4 by vertical angle theorem. And once we have that true, we also know that angle 4 is congruent to angle 6 by corresponding angle postulate. So now that we have these two statements, we can conclude, as we wanted to, angle 2 is congruent to angle 6 because transitive property. Transitive property of congruency. And that works. So that came together very well, and part of it was, like I say, the way they labeled it, they sort of showed how we might want to go about doing that. If they didn't give us those angles, we might have had some other ways to do that. But obviously we would like to use postulate, and the vertical angle theorem was also one of those 4 postulates and theorems that they suggested us using on that worksheet that we did. So let's moving on to number 2. We have another situation where they gave us parallel lines, and that opens up to use some of the theorems that we have. Specifically, the postulates, corresponding angle postulate, it works nicely. So in this case, we're trying to prove 3 and 6. We're trying to prove that these two angles are supplementary, that they add up to 180. So we want to go ahead and again state our given information. L's parallel to M. That was given to us. Once we have that, we want 3 plus 6, those measurements adding up to 180. Well, in that case, let's get that whole 180 idea out there. We want 3 involved with one that we also know through a postulate, which would be angle 2 and 3. The measures of 2 and 3, add those together, and since it's a linear pair, they should add up to 180. That's a linear pair postulate. Now, looking at this, we'd like to be able to get 3 and 6 together. Well, 2 and 6 have to be congruent because the parallel lines give us our corresponding angles congruent. So I can say angle 2 is congruent to angle 6 by corresponding angle postulate. Now remember, that's congruency. So to get that congruency into a measure that we can substitute in, we need to use the definition of congruency to say that the measure of angle 2 is equal to the measure of angle 6. And that is by, not by the corresponding angle postulate, that's by the definition of congruency. Definition of congruency. And once we have that, now we can substitute this into here, and we get our measure of angle 6 plus our measure of angle 3 to equal 180. And that's through substitution. Property. Substitution property. And now that we know the sum of these two angles add up to 180, that's simply the definition of supplementary. We know that angle 3 and angle 6 are supplementary. And that was by definition of supplementary. Next, let's look at the next one in the bottom of the page. We are given two sets of parallel lines, which opens up a lot of relationships. But let's get that first. A is parallel to B, and C is parallel to D. That was given to us. And let's look at what they want to prove. They want to prove that this angle is congruent to this angle. Which, with what they've given us, since we want to stay with congruencies, I would say 1 and 4 are obviously congruent by alternate interior angles. And then we have corresponding angles to make those, and then the transitive property. And that, it's going to be as simple as that. Getting too involved, it gets a little messy, and it would be definitely longer than 4. We could do it if that's all we had, but I think the way that I have sort of seen that, I think that's definitely the way I would want to go. Angle 1 is congruent to angle 4 by the alternate interior angle theorem. And that makes these two congruent. And then corresponding, we can get angle 4 congruent to angle 3 by corresponding angle postulate. And now that you have those two, 1's obviously going to be congruent to 3 by the transitive property. That's how we can justify that. Transitive property of congruency. So, once again, make sure you're marking what you know, what you're trying to get, and try to find some method of working your way around the picture to get there. Number 4, moving right along here. We want to go ahead and prove that the same side interior angle theorem. So we're not going to use the same side interior angle theorem to prove it, and that's one of the misconceptions a lot of students will have and make mistakes on. I want to make sure that we realize that what we have here, let me get that square in your view, measure of angle 3 plus the measure of angle 6 was given to equal 180. And here we're trying to prove parallel lines. Therefore, we're going to want to use one of those converse theorems that allows us to prove lines are parallel. This is where we're given. We were talking about these two. Now, if that's true, what else is 6 supplementary to? 7. And if those are both supplementary, if 3 is supplementary to 6 and 6 is supplementary to 7, I think these two should have to be congruent. But we have to do that mathematically and link it together. So in this case, I'm going to say the measure of angle 6 plus the measure of angle 7 equals 180 by linear pair postulate, LPP. Once I have that, now I can use substitution or the transitive property. They definitely can interchange a little bit Transitive is a little more specialized term, and in this case it would work. Measure of angle 3, measure of angle 6, add up to the same as the measure of angle 6 plus the measure of angle 7, and that's by the transitive property of equality. Once we have the transitive property worked out there, now if we go ahead and subtract measure of angle 6 from both sides, we get the measure of angle 3 equal to the measure of angle 7, which is nice. The thing with that is, well, how do we just do it? Well, we subtract it. And that's a property of equality. We subtracted from both sides. Now, converse of the corresponding angle postulate works for congruency, not necessarily equality. So we need to go ahead and state that angle 3 is congruent to angle 7, and that's by definition of congruency. And then now we can say L's parallel to M, L's parallel to M, and that's because these corresponding angles, the converse of corresponding angle postulate allows us to say then that L is parallel to M. One more example. Getting comfortable with these proofs, hopefully. Now they left everything blank. Now don't get intimidated by that. That's not a big deal. We're just going to need to take our time and go ahead and write that out so that we're going to have steps, and we don't know how many steps. They're not suggesting any number because they didn't give us anything. That's all right. We're up to it. L's parallel to K, and M's parallel to K. And that's given information, so we write given. We've justified why we believe that to be so. Now, if those are parallel, if L and K are parallel, if L and K are parallel, these are parallel, and we have M and K parallel, we're trying to come up with the fact that what we're trying to prove here now is that L and M, these two are parallel. Well, how we're going to do that is we're going to do through angles. So number 2, and then notice they numbered angles. We know that angle 1 and 3 are congruent. Angle 1 is congruent to angle 3 by corresponding angle postulate. As do, we know that 1 and 2 are congruent. By corresponding angle postulate. And now through the transitive property, we can say that angle 2 is congruent to angle 3. Transitive property of congruency. Once we have that, once we know that 2 is parallel to 3, now we can use the converse corresponding angle postulate to say these two lines are parallel. So those are all parallel. So now 5, L and M, as we wanted to prove, L is parallel to M, which is exactly the statement there. So we've proved. And once you get, notice as we've done each of these, converse corresponding angle postulate allows us to make that last step. As we've proved all these, given information was always the first line. If you see all blank here, don't get intimidated by it. You know that you can place these in the first line, and place this at the end, and you just got to fill in the middle. And that does take some work, but it also makes this an interesting mathematical, puzzle almost, if you will. So thank you. Good luck on your proofs, and I hope this has helped.